Question 20. This is our 6 marker. Now before I begin, I just want to say that in general 6 markers are marked in terms of 3 levels. So level 1 being minimal physics knowledge, level 2, which is 3 to 4 marks, demonstrating understanding of physics, and then level 3, which is 5 to 6 marks, is the candidate or you have demonstrated a very clear and detailed understanding of the physics and have outlined your work in a very clear, logical way. For 6 markers, I always tell my students to not be afraid to write down their answers in terms of bullet points. It might look a little bit too artificial, but to be honest, it helps keep your thinking laid out in a very logical way, so why not do it? Okay, so let's have a look at this. A student investigates if lamps are brighter in a series circuit or parallel circuit. He sets up 2 different circuits, A and B. Okay, fine. State which circuit will have the brightest lamp and explain why. I don't like underlining lots of things, but I'll definitely put something here because we do actually have to come to some kind of conclusion. So state which circuit will have the brightest lamps and explain why. We'll need to have that somewhere in our answer. In your answer, include the variables the student will need to control this experiment. Let's go for level 1 and show that we actually have some idea what's going on here. We've got our 2 circuits. Our student wants to figure out whether the lamps are brighter in series or parallel. Well, let's tell them what they're dealing with. Circuit A is a parallel circuit and circuit B is a series circuit. Probably also worth mentioning that there's only 1 cell in each one. Each circuit has only 1 cell. This kind of answer might get us into the 1 or 2 marks territory already because we're demonstrating some kind of understanding what's going on in the question. Let's knock it up a notch. In parallel circuits, the current is split at junctions. So in this circuit, as follow conventional currents, it's split at these junctions here. The total resistance of circuits in series is less parallel, is less. Let's pretend I didn't write that and think about what I'm saying first. The total resistance of components in parallel is less than those in series. And with that, we can say the current through the components in A, which is our circuit A, will be greater than in B. At this point, we've probably said enough to explain, well, to state which circuit will have the brightest lamps. So we'll just round that up. So therefore, lamps in A, circuit A, will be brighter than those in B. So far we've got 3 well articulated, well, if I ignore all the stuff that I've scribbled out, articulated points. Just want to make sure that we've made the most of this. In your answer, include the variables that the student will need to control. That's something worth mentioning. If they've asked for it, they probably want it. So it seems a bit silly because they've given us our circuit diagram, so we know exactly what they're working with, but let's just clear some things out of the way. The student should use the same type and number, I guess, of cell in both circuits. Seems a bit superfluous to mention this, but if this battery had a greater potential difference, we might end up getting a larger current and therefore brighter bulbs in B. But we've already argued that A has a greater current through our bulbs, which kind of implies that we've expected the cell to be the same in both circuits. So let's make that clear there. So the student should have the same type and number of cells. So have that 1 cell and make sure it's the same voltage for each one to keep it fair. Whilst we're on that note, let's make sure that the lamps are the same. So ensure lamps are of the same resistance and have the same number of lamps. So this seems a bit superfluous saying the same number of lamps. There's clearly 2 in this one, clearly 2 there. The earlier point that we've mentioned, ensure lamps are the same resistance, is good though, because we could have 2 quite high resistance lamps in circuit A, which means that they'll have some kind of brightness. If we had 2 different lamps here which are much less resistance, we might end up having brighter lamps in B. So our logic that we've just mentioned in these first 3 paragraphs require our lamps to be exactly the same. So if they have the same resistance, let's say this was 5 ohm, that was 5 ohm as well, this would be 10 overall, and this would be 5 ohm there, 5 ohm there, it'll be, well, I know off the top of my head it'll be 5 ohm overall for our circuit, which allows us to have our higher current through both of our labs. Just before I finish, I want to mention that some of these things that I've crossed out is a little bit deliberate, genuine mistakes, but I'm glad I left them in because it's worth reading through what you've written to make sure that actually makes sense. So the total resistance of components in parallel is less than those in series. Yes, that is true. It seems a bit silly to read through some answers that you've just written, and I can't recommend it enough. And seeing as that we've written our answer in bullet points, it makes our proofreading afterwards just a little bit nicer for us. So if you were to write all of this in one big paragraph, it'll be a bit tedious to read through it and check if your physics was right, which is why I suggest doing little paragraphs there, so that when you're checking it yourself in the exam, it's much nicer to read through and check, oh yeah, this bullet point here, parallel circuits current is split at junctions, total resistance of components is parallel, less than those in series. Yep, I can check that because it's easier to look at because it's separate from everything else. That's all I want to do for that one, I think.